Next presentation, Victor Soifer, President of Samara National Research University, named after academic Korolev. Photonics for smart home and smart city. That's the topic of his. Unfortunately, his tight agenda didn't allow him to join us live, but we have a video and we have very interesting information from the pre-recorded video of his. Good afternoon, dear participants of AIJ Forum. Today I'd like to share with you the role of photonics in artificial intelligence, and I'd like to demonstrate to you that photonics today is one of the AI drivers. After a short introduction, we will discuss how photonics influences the quality of human life, the quality of environment. Afterwards, we will touch upon some tools and equipment which implement AI on the basis of photonics, and speak a little bit about the market of photonics. First and foremost, please pay attention to the following. 19th century can be considered the age of steam, when steam machines appeared and steam mills appeared and many other equipment. 20th century is the age of electricity and electronics. 21st century we're living in can be called the age of photonics. All our gadgets and devices contain electronic and photonic components. These are screens, first and foremost. We take part in different kind of multimedia events and processes, and we can see how different pictures appear, sometimes 3D pictures. This is also about photonics and many other things which is used not only in our routine life but also in the military equipment and different other industries. And fiber optic is also about photonics. What is photonics basically? What is it focused on, and what's its purpose? Its purpose are field of study of fundamental and applied aspects for optical signals processing and creation and design of different new devices based on this fundament. Nanophotonics is another area. It has basically the same purpose, but the size of the devices it's handling and it's dealing with, and the tasks which are solved when light interacts with these obstacles, it's very small, tiny, nano 10 in minus 10 in the power of minus 10. This is very important for production of chips in microschemes, microchips. As a result, it is needed to use photonics on the chip basis in a normal view for electronics and electronic purposes. Let's speak about photonics in social and socio-economic challenges which appear during the digital transformation of the society. We have a huge source of information, which initially is an image, video information, and these are video surveillance systems, these are systems of Internet of Things, these are sensors which are now installed on all devices. It's the Internet of All, another notion of the same term. This is autonomous and pilotless transport. This is digital healthcare, which generates a huge amount of images to be processed. And all this, in the end, brings us to the fact that we have the growth rate of data by dozens of % every year from such kind of systems. And unfortunately, 90% of this information stays unprocessed. It is stored somewhere or get lost. It is related to the fact that digital processing machines cannot digest this huge amount of information. That's why they say now it's necessary to create quantum computers, photonic computers, which would work much faster and will be compatible with these amount of tasks. Of course, we are not able to speak about them in detail today. A big role in photonics, a big role of photonics is marked in the quality improvement for the human being's environment. First and foremost, due to monitoring of everything, monitoring of the environment, product state, control of materials and buildings. Different structures are made of hybrid visualization systems, virtual reality, and many other things, which allow, as a result, to make the life of the human more comfortable. Let's stop a little bit in detail on autonomous transport and self-driving vehicles. What do we have to have in mind? We should have a low latency, immediate response of systems to different sort of situations, which appear. All data channels should be secured to prevent any intrusion or any compromising and failures as a result. We have to have universal access to information everywhere and at all times, and we have also be capable of unlimited scalability. This makes new demands for navigation system and computer vision systems. Today we have to position everything with the precision of centimeters. We have to provide positioning in absence of satellite signal, which happens sometimes. And the modern car, modern vehicle is equipped with a big amount of different tools and instruments. All those tools are implemented and are operating on Photonics platform. These are cameras, normal cameras, these are short-range radars, these are lidars, these are radars with the optical source of irradiation, and long-range radars in the end. All that allows for the vehicle to move, and all these sensors and instruments allow to drive the vehicle without the pilot, and so more and more self-driving vehicles will appear in the streets and on the roads. Now let's speak about the improvement of and the better quality of life. Many things can be touched upon here. Let's look at the first picture on the left. If previously signal transmitting systems on the planes were wired, were based on metal, now they are completely replaced by fiber optic, which can protect the flying vehicle from lightning and from electromagnetic impacts, and improves the safety of our life as a result. Augmented vision, dangerous objects identification. Using different wave ranges, now it is possible to see what is not seen by a normal eye. It's an introscopic view, so-called introscopy. We can assess the quality of product at earlier stages and do not use low quality of products and food. A big role now has such area of radio photonics, especially in radio positioning. If we had radio photonic systems, this Falcon accident didn't happen, which happened in Vnukovo airport, and as very tragic, very lethal result. Radio positioning and electronics go hand in hand here. Environmental safety improvement. All complex structures are equipped with sensors. These are fiber sensors, fiber optic sensors, which just cover the whole. For example, let's take an airplane. We can have taken a bridge or another big structure. So all these sensors give complete data on the status of the mechanical structure and on its danger danger or risk, if there are any risks there, which allows to take proper decisions. We can speak about the use of photonics in forensics for analysis of some smaller substances, trace elements, in security systems, in agriculture. Well, photonics is widely used there when multispectrum instruments allow to monitor the soil systems, make decisions on special humidification, and provide more fertilizers, less fertilizers. We can endlessly speak about medicine. We cannot go away from systems related to photonics. This is CT and MRT equipment, many other things, and equipment which we are using very widely, and they give more benefit for the life of people. That's on the quality of human life. Well, let's speak about the city. Normally, people live in cities. There are a lot of systems in cities and towns which provide higher comfort of living, and they are going to be developed. Let's take the simple streetlight system. Apart from its main function, it will have also other additional functions. For example, make these lighting more comfortable, change the spectrum from yellow to blue or the other way around. Using these electric poles, you can support the atmospheric connection between those poles and cover the city with the full wireless network connection. It's possible to provide information exchange, different information exchanges in this grid. We can install the system of sensors to monitor environment, the pedestrian and traffic control system, help of pilotless and automated transport, transmitting signals for precision navigation, for Internet of Things, and for many, many other things. So photonics will develop in a smart city, and smart lighting systems will appear too. Just for one example, just as an example, I show a very ultra-compact personal use device. This is a simple smartphone with an attachment which provides personal monitoring of the environment, features in different spectrum channels. It can be used at home, it can be used when shopping, when checking products, and I hope that such devices will be widely used in the end, and we will not they'll get rotten fruits when we come home. We can detect it right in the store using these devices. Sensors, such sensors which I described initially, they can be used for quality of products. This is naturally, but they also need to be for research, for medical diagnostics, for monitoring of environment, for controlling oil and gas and food products, for food industry controls, and for safety systems like for detecting explosive. Such sensorics, such sensors based on photonics will be constantly developing, and the control of liquids and gases will be present and will be developed.
So that covers photonics. Now let's speak about photonics on chip. That's a very relevant trend. But you know, the point here is that there is a Moore's law which says that there is certain dependency between the increase of computational power and time. It has a linear law, but during the recent years it doesn't really fulfill. Why? Well, we have quite a lot of conductors in these electronic systems, and they provide a lot of heat, so you cannot really compact even more. We use fiber optics, we use photonic integrated circuits, which are used specifically to transfer information. We use light transmission. It doesn't really heat up the fiber optic conductor or a track conductor which uses integrated AIJs. We use photodetectors, circle and ring integrators, ring resonators. On the left you can see a picture by IBM. It's a fragment of a chip which joins elements from, well, it joins electronic and photonic components. These kind of elements will be more and more prevalent. Artificial intelligence for photonic devices. Obviously, now they are used for various systems. We use neural networks, optical neural networks, and transition of neural networks to photonics base is very interesting thing. They provide better calculations, they are compact, they consume less power, and they are resistant to radiation and electromagnetic interference. These kind of networks appear, and soon enough they will be present in all the devices like robots, autonomous cars, UAVs, drones, and so on. But we have to understand that neural network training is performed at the electronic level in a computer, and then trained neural networks for some specific tasks. An optical neural network will be in this or that device, so they're pre-trained at the electronic level. That's the development and evolution of artificial intelligence based on photons, on photonics rather. Here we can see some promising outlooks. It's really complicated to perform matrix transformation, like Fourier transformation, which is used all the time. It's really complicated in an electronic computer, even when using fast algorithm. But when we combine photonics and electronics, when we have this matrix transformation, Fourier transformation is much more efficient in that case. And finally, on the slide we can see a device which a photon in and of itself is a spectrometer which splits the input signal into elements, then optical neural network analyzes it, and it can separate specific spectral components, find some danger areas, some risks, and split it and define the composition of liquid or gaseous object. So not just photonics, not just pure photonic system, but combined photonic system will soon become part of our routine life. That's all I wanted to cover here regarding the photonics, but let's say a few words about the market. Potentially is estimated in $1.5 trillion USD. Consumer market for entertainment, that's defense, security, and law enforcement. Biomedicine, alternative energy, which I completely missed and skipped. We have solar batteries which generate as much energy as all hydro stations, hydropower stations provide right now. So solar energy is and will be really wide used. These are sensors, optical communication, displays, which we always use, semiconductors, and more. But we do not have this great production foundation which we have in the case of electronics. We still need component bases for photonics, which will be just as universal as we have in electronics. I think in the nearest future we will have this kind of component base, and that is why I want to say that 21st century will be the age of photonics. Thank you for your attention.